This video shows how to import a ship, place an antenna, and see installed antenna pattern, and also rotate the antenna around the axis and see how it is going to impact with respect to the ship body. So to do that one, import a ship model. So go here, go to modeler, and let's take this destroyer. Unit is meter. Always use this import as a lightweight faceted body to import big ships in no time. So now the model is here. So you can see the mesh which is there in the STL body. If you want to uncheck that mesh view, uncheck here and select this one, and let me give some color which is similar to naval ships. Okay. And what I'm going to do is I want to keep my antenna somewhere here. I will create a small line which will pick somewhere here. And I wanted to keep my antenna just somewhere here at some certain height. So keep this, automatically pick the center of that line and say move that coordinate by some distance, let's say 0.5 meter. Now I have this antenna. You can import an HFSS pattern or HFSS design already simulated. Otherwise, go here. If you don't have it, go here and say parametric beam antenna. This is my antenna. Put some beam width. It will automatically generate an antenna pattern with that beam width. And what I want to do is I want to rotate this antenna around 360 degree. So I'll say rotate. Let's put this is 90 degree. So this is going to rotate in horizontal direction. You can create any rotation. Say antenna rotation, some variable you created. So this is going to rotate. This currently 0. That's the reason it's coming back. The idea is to create a variable uh, and then run a parametric analysis. Before running the parametric analysis, you need to go here and set up that which frequency you wanted to simulate and what is the infinite sphere you wanted to compute. Infinite sphere, you will specify the radiation in phi and theta and what resolution you want. You can set it up and you need to add that inside the here infinite sphere. So make sure you're simulating with the more number of cores. So I'm running with the 4 and check how many cores you have it in your machine. For example, here if I go, I have up to 16 core. I can simulate up to 8 or 16. There is no problem. If you have a sufficient number of HPC pack, you can increase it. So once this is done, what you need to do is I set up a parametric sweep. So I'll do one thing one more time, parametric add. Then I have my antenna rotation start from 0 to let's say 350 in every 10 degree so that it will go for all 360, 35, 36 simulations and go make sure the setup is clicked, make sure the save field is also enabled. And once you set up that, what you need to do is animate it. So the animation will show you how this antenna going to rotate around that location. So assuming that this is a place I'm going to place my antenna and that is going to rotate. The idea is to see because of this all metals and other thing how the radiation pattern is going to be. Uh, for doing that, one more thing which I need to do is in the infinite sphere, may the global coordinate of this ship is somewhere down the line. Okay, so somewhere here, which may create some problem when you are not considering the radiation sphere to display here. If you are not using a basic infinite sphere, the installed antenna pattern will overlay over here. But if you want to see over this location, go back here and say, instead of it will be like this. Instead of that, you say, I want to see for this coordinate which we created at this location. With that, you can just run it. Run the parametric analysis, I will recommend. So run it. It will go for like 36 simulations. So you can see it's going to start that simulations soon. I already completed the simulation part. I'll come back to the first design, and you can see this is a radiation pattern which is plotted. So I'll I'll show you how it is can be plotted. This is a location, and you go here in 3D polar plot and say gain in dB and families, what frequency and which antenna rotation you wanted to see. Everything will be visible here. So 0 degree if I want to see, click new report, it will get generated. If you want, you can control the scaling. Go to R axis row and then enable these values and say minus 25 dB is a minimum, so that this will get corrected and you can see the radiation pattern. Now that radiation pattern, once you see, you can enable overlay over here. You will be able to see the internal line pattern and this is the installed radiation pattern. So there are some transparency issue. You can just go here and go here and say this one, reduce the transparency to 0 and click apply. Now become pretty good. If you want to reduce or increase it, you increase the scaling. So I'm going to reduce it to 0.15, and now you can see the radiation pattern here. And I wanted to see if, since we simulated for full 360-degree, what I would like to see is the radiation pattern during that different rotation axis. So click here, click OK. Now you can see how the radiation patterns are getting changed because of these aircraft bodies. And you can, if you want, you can just hide this rotation axis by clicking in this and always increase or decrease the speed of animations through this way. And once your visualization orientations are finalized, let's say I wanted to see something like this with this axis. If you want, you can just close these windows, reduce it, make sure you have a better window to visualize everything, and turn off the grid, turn off this. And if you want to turn off this axis, then go back here, view coordinate system, hide it. Now it is nothing but your antenna is rotating. I wanted to export it, export. Uh, I'll go and export it somewhere in my download folder. Once it's done, your video is saved in the download folder. That's all to export the video.